This is example 4.3.2. It says a cannonball is fired from 100 meters per second. If it lands 200 meters away, what two angles could it have been launched from? So what we have is we are launching a projectile. It lands 200 meters away, and we are trying to solve for what angle it was launched at. So we are trying to solve for theta. We have an initial velocity that we're given as 100 meters per second. We have gravity, as always, is 9.8. And we are given the range as 200 meters. So we're going to use the formula R equals VI squared sine 2 theta over G. Our solution, we're going to say, okay, the range is 200 meters is equal to 100 squared sine 2 theta, all of that over 9.8. So we're going to go ahead and solve. We're going to isolate the sine term to begin with. So we're going to multiply both sides by 9.8 divided by 100 squared. And when we do that, we're going to get 200 times 9.8 divided by 100 squared, and you get 0.196 equals sine 2 theta. Now remember, to get rid of a sine term, you have to do the opposite, which we call the inverse sine, which is sine to the minus 1. Do it to both sides, and when you do that on your calculator, remember it's the second sine button. So we hit second sine 0.0196, excuse me, it's just 0.196, and you get 11.3 equals 2 theta. So now we can divide both sides by 2, and we get theta is equal to 5.65 degrees. And that's the first answer. But it says, the question says, what two angles could it have been launched from? It turns out that any two angles that are complementary, in other words, any two angles that add up to 90, will actually land in the same place. So if we do 90 minus 5.65, we get 84.35 as our second angle. So let's verify this prediction just by plugging it into this equation and trying to see if we get our same 200 meter range. So you plug in, you say 100 squared times the sine of 2 times 84.35, close parentheses, divided by 9.8, and when you do that, you get 199.95, which is almost the exact same thing as 200. The reason why it's just a little bit different is we did round these terms just slightly.